In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. For as long as there have been people to look up, the night sky has been an endless source of wonder and mystery. It's easy to understand why. Like so much of the natural world, the stars, planets, and other objects that fill the heavens exist in plain sight. But unlike just about anything else, they also exist beyond human reach. For our ancestors, this made the night sky a supernatural place. A place they eventually filled with mythical beasts and the gods. In time, this mythical view gave way to a more mathematical understanding of the sky. But the stars remained as mysterious and distant as ever. Unable to touch the heavens, humans eventually came up with an ingenious device to bring the heavens closer. It's called the telescope. Although telescopes today vary in size and complexity, the underlying principle is always the same. At its heart, a telescope is a device that magnifies our sight. Using mirrors or lenses, and often both, it makes distant objects appear closer. In this way, the telescope can reveal details about our universe that are inaccessible to the naked eye. Equally important, a telescope is like a funnel for light. It's wider at one end, and it grows progressively narrower as it gathers and concentrates far more light than would otherwise pass through the narrow pupil of the human eye. And this is why, through a telescope, objects that are dim appear brighter, while objects that are too faint to be seen at all emerge from the shadows. Because it extends the power of the human eye, the telescope was the tool that finally allowed astronomers to see what kind of universe we live in. As it turns out, it's a far larger and deeper universe than our ancestors ever imagined. It was only after the telescope was invented that people began to grasp that our entire world is just one planet among many. And that our sun, in turn, is just one star in a galaxy we call the Milky Way. A galaxy that holds 100 million times the number of stars that can be seen with the naked eye. Thanks to the telescope, the Milky Way was itself revealed to be just one among billions of other galaxies. Great islands of matter and light adrift in a cosmic ocean that is as vast as it is dark. But for all the power the telescope brings to the study of our universe, for nearly 400 years, it was limited by a factor beyond human control. For Earth-bound stargazers, the atmosphere is a fickle window on the cosmos. Its constantly shifting patterns mean that our exploration of the night sky is conducted at the whim of the weather. Even on the clearest night, the air above Earth is always in motion, like a turbulent cauldron of invisible soup. This ever-changing turbulence bends and distorts the incoming light of stars and galaxies. Even for the biggest and best telescopes in the world, the fine details of our universe are blurred away. If the effects of Earth's atmosphere could somehow be eliminated, we would improve our view of the universe 100-fold. It would be the biggest single leap forward since the invention of the telescope. Humanity took that leap. The Hubble Space Telescope was lofted into orbit aboard the Space Shuttle Discovery.
Lots of clearance. Coming starboard nicely. A little bit more.
Okay, let's do it.
Okay.
Years in the making, the telescope was named in honor of Edwin Hubble, the celebrated American astronomer who first proved that galaxies exist and demonstrated that our universe is expanding.
Okay, we have a go for release. Okay, Charlie.
With its unique status as the first large telescope to operate outside the limits imposed by the atmosphere, astronomers hoped that Hubble's namesake would lead them to equally important discoveries.
Houston Discovery.
Go ahead, Charlie.
Okay, Story, we've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to filter state.
Expectations were running high, but what astronomers saw was not what they expected. Within days of Hubble's launch, it became obvious that the telescope could not see properly. Images that should have been crisp and detailed were blurry. The problem was soon identified. A slight but fatal flaw in Hubble's main mirror meant that it was unable to focus incoming light. The flaw had been introduced years before due to an error in the way the mirror was tested during its manufacture. It had gone unnoticed until the Hubble was already in orbit. Fortunately, the Hubble's disastrous debut came with a silver lining. Because the flaw in its mirror was so well understood, it was possible to craft a precise set of corrective optics. It was the astronomical equivalent of contact lenses. The result was spectacular. After its dramatic repair in December of 1993, the out-of-focus images that Hubble had been beaming down to Earth were replaced with views of breathtaking clarity. The pictures were not only better, they were the best astronomical images in history. For the first time since the invention of the telescope, astronomers had a new way of seeing the sky. One that would change our view of the universe forever and fill our eyes with images of breathtaking beauty. The age of Hubble was underway. Sometimes the power of great art is the way it reveals the extraordinary within the ordinary. In the universe, there's nothing more ordinary than the death of an average star. But when seen through the Hubble Space Telescope, this unexceptional event becomes a scene of stirring beauty and rebirth. When a typical star runs out of energy, it cools and expands. Like a dying gasp, its outer layers are puffed outward into space, forming an expanding bubble of glowing gas. As the bubble grows more diffuse, the star's core is soon laid bare. It is now a tiny but intensely hot white dwarf star. The intense radiation it gives off energizes the expanding gas, which takes on the appearance of a luminous flower blossoming in space. It's called a planetary nebula because over a century ago, astronomers thought that the rounded shapes of objects like this looked like distant planets. For the Hubble, a planetary nebula offers more than an opportunity to study the final stages of a star's life. Each one of these colorful blossoms is unique, like a flower in a painter's still life. Among all the objects in the universe, they have added some of the most beautiful and breathtaking images to Hubble's collection. And they are as diverse as they are beautiful. While some are symmetrical and round, others have turbulent and complex structures. Here, Hubble zooms in on one of the best examples. This planetary nebula resembles a bow tie. Its complexity tells us that the nebula likely formed in a series of ejections, rather than one great outburst. This is also true of the Cat's Eye Nebula. Astronomers are still trying to decipher the events that formed this unusual object. Near the center lies a series of intersecting shells that were ejected from the dying star over the past 1,000 years. Two jets of material have pierced these shells on opposite sides. Meanwhile, these structures sit within a larger succession of concentric shells, which were released over thousands of years in regular bursts and which now make up the outer portions of the Cat's Eye. One theory that may help explain the unusual shape of the Cat's Eye holds that the nebula's central star is not a single white dwarf star, but two stars in a close orbit around each other. The idea that the presence of a second star can greatly complicate the shape of a planetary nebula is already known from another striking example. Astronomers call this object the red rectangle. Here, it's believed that two stars are in orbit around each other, with a ring of dust surrounding both stars. When one star aged and began ejecting its outer layers into space, the ring became a waistband, forcing the material to move outward in two narrow cones rather than in a spherical shell. The Hubble can also show us many other examples of a planetary nebula with an hourglass shape. The cause of this shape may not be the same in all cases. Different theories suggest that the gravity of a companion star, large planets, or simply the interaction of gas with a star's magnetic field can explain their remarkable forms. Now, with Hubble's penetrating eye, astronomers are zeroing in on some of the largest and brightest examples, searching for clues to their formation and structure. They have good reason to be curious. A planetary nebula may be lovely to look at, but its true significance to us lies in the nature of the material it releases into space. The vivid color in this Hubble image corresponds to different atoms emitted by the dying star. In this case, the green light represents oxygen atoms, while the red color is due to nitrogen. The shells of stellar debris expelled by dying stars are not simply made of atoms, the basic building blocks of matter. They also produce molecules, combinations of two or more atoms, including molecules that are instrumental to the origin and development of life. In the past, it was believed that such molecules would be destroyed by the intense radiation from the white dwarf at the center of each planetary nebula. With Hubble's help, astronomers have learned this is not the case. Among the best locations to study this exciting new development is the Helix Nebula. It is one of the nearest examples of a planetary nebula to Earth, which makes it an ideal target for the Hubble. The catch is that the Helix Nebula is large, much larger than the Hubble's field of view. To capture the entire nebula, Hubble took many separate images, which were combined to make a grand mosaic. Normally, there would not be enough room in Hubble's schedule to dedicate so much time to a single object. But a few years ago, a passing cloud of meteoroids forced the telescope to be placed in a protective mode. In order to shield its vulnerable primary mirror, Hubble kept its back to the incoming meteoroids, and as a result, had to stare at the same part of the sky for many hours. Fortunately, that part of the sky included the Helix Nebula. So what has Hubble found in this incredibly detailed view? Like other examples, we find the Helix Nebula is composed of nested structures, one inside the other, each blown off in different episodes during the central star's transition to a white dwarf. But because the helix is so much nearer than other examples, astronomers can see much more detail within those structures, and they have a better chance to explain how they formed. One result of this investigation is that it's now clear the helix contains a pair of gaseous disks that are tilted with respect to each other. This reconstruction shows what the Helix Nebula might look like if viewed from another angle. At this angle, the two disks are more obvious. But exactly why they are oriented in this way is not so easy to understand. Perhaps, as in so many cases, it's because the star at the center of the helix is really two stars in one, which has complicated the structure of the expanding nebula. Even more intriguing than the helix's overall shape are the many tiny clumps of material that show up on the inner edge of the nebula's glowing rings. Astronomers have dubbed these objects cometary knots because they look so much like comets with their long streaming tails. These knots cannot be comets, however, because they are too large. Instead, it's believed they are denser clumps of material that formed within the expanding shell of the Helix Nebula. As the fast-moving stellar wind from the central star pushes outward on the nebula, the clumps are gradually exposed. But while the bright gas in much of the nebula is seared by the incredible heat of the central star, the molecules within the cometary knots remain protected. Here, carbon-bearing molecules can form and survive until they are eventually dispersed into interstellar space. This is why places like the Helix Nebula are cosmic flowers in more ways than one. After they blossom, they not only dazzle us with their fleeting beauty, as Hubble has shown, they are also scattering the seeds of future life. In the beginning, there was light. So much light that when the universe formed, every corner of space blazed white hot. But it didn't last. As the infant universe expanded, it cooled and its light faded. For 200 million years, darkness reigned. And then, light was reborn. It was gravity that gave the universe its new look. Gravity drew matter together into vast swirling clouds. While deep inside the clouds, dense concentrations of matter coalesced and began to glow. As these concentrations grew, the pressure and heat at their cores became enormous. Until, with a flash, nuclear reactions ignited. Suddenly, a new kind of light was shining in the universe. The light of countless newborn stars. When you think of the elements that make up a painting, you might think of color, form, subject, but you probably don't think about the light that lets you see the painting in the first place. In space, it's just the opposite. There, light is the subject, especially the light from stars. In fact, it's the way starlight interacts with the matter around it that makes the universe so revealing to astronomers. The Hubble Space Telescope reminds us that in a universe painted by starlight, beauty and science often come hand in hand. Like no other instrument, the Hubble is built to explore the finest details in the light that it gathers from the stars. Where does starlight come from? In the core of each star is a natural nuclear power plant that turns hydrogen, the most abundant element, into helium. This reaction releases energy, much of which works its way through the star's interior until it's released as light. Once starlight is traveling freely through space, it can illuminate the star's surroundings, which may absorb, reflect, and re-emit the light in countless ways. This includes lighting up any gas left over from the star's formation. Normally, this interstellar gas would be transparent, but when it's energized by nearby stars, it becomes ionized and emits light of various colors. Here on Earth, the same principle lights up a city street at night with colorful neon signs. Gas may add color to Hubble's canvas, but it's dust that creates some of the most striking views in space. The dust comes in the form of microscopic grains, no bigger than particles of smoke. But when trillions of them get together, they block and absorb light. Our galaxy is full of dust, and when there's a cloud of glowing gas in the background, the dust stands out in dramatic silhouette. One of the best-known examples of this effect is the celebrated Horsehead Nebula. From a distance, it appears like a horse-shaped hole carved out of the surrounding gas. But looking more closely, Hubble reveals the Horsehead Nebula as never before. A towering pinnacle of dark dust so vast, it would take a beam of light 2 years to cross from the tip of its nose to its mane. Such dark clouds are often found in regions where new stars are forming. They are full of elements like carbon and silicon that are essential for creating solid rocky planets like Earth. Once, the rocks and dirt that make up the ground beneath our feet began as tiny grains of dust swept into a dark cloud like this one. If all dust did was block light, it would still make the universe a more beautiful place to look at. But dust can also do something even more interesting. It can scatter light. To witness this remarkable spectacle, the Hubble cast its gaze across our home galaxy, the Milky Way, to a star so brilliant and so distant, its light takes 20,000 years to reach us. Normally, such a star would appear as nothing more than a faint speck of light. But this star is a giant, one of the brightest in our galaxy. It is also on the verge of running out of energy. And like a dying flame, it surrounded itself in a smoky cloak of dust. In early 2002, the star brightened suddenly and then faded. As Hubble watched, the brilliant flash produced what astronomers call a light echo. Month after month, Hubble recorded the initial flash of light from the star as it scattered and reflected off the surrounding dust. Viewed in sequence, the result creates the illusion of a cosmic flower in bloom. Closer to home, this sequence of Hubble views of the planet Mars shows the dramatic effect of scattered light. Normally, the surface features of Mars make for an easy target with the Hubble, until a planet-wide storm wraps Mars in a cloak of fine airborne dust. The Pleiades, a nearby cluster of stars also known as the Seven Sisters, plows into a cloud of dust while on its trek through the galaxy. In this image, taken by a ground-based telescope, you can see the dust scattering the light of the cluster's young blue stars. Moving in for a much closer look, astronomers have used the Hubble to explore the dust in fine detail. The telescope has revealed wind-swept features that are caused by the force of the star's bright light pushing the dust back. The idea that light can move matter may seem surprising, but it comes straight from the most fundamental laws of nature. light carries energy, and when light is absorbed by fine particles of dust, the energy makes the dust recoil in response. When this simple effect plays out on the grand scale, it means that starlight isn't just the painter of our universe, it's the sculptor as well. Nowhere is the sculpting power of starlight more apparent than in the fabulous Eagle Nebula. This dramatic Hubble close-up shows part of a dark column of dust silhouetted against a background of glowing gas. Stars are forming before our eyes in this delicate dusty pillar, even as it is shaped and eroded by the intense light from other stars within the nebula. Hubble's unprecedented view of the Eagle Nebula offers vivid proof of the powerful force that light can exert. Like a desert wind that builds and shifts mighty sand dunes, here, light is the invisible hand that guides both the creation and destruction of pattern and complexity in space. Everywhere we look in the universe, our view is determined by a graceful intertwining of matter and light. When viewed at the scale of an entire galaxy, the glowing clouds of gas that are lit up by the energy of newborn stars stand out like snow-capped mountains, while the tendrils of dust that thread their way between the star-forming regions look like networks of lakes and rivers. Pulling back, Hubble shows us how these patterns of light and dark shape our impressions of what galaxies look like, and provide key insights into our understanding of the forces that create their appearance. With Hubble, we can see that we live in a universe not only painted by light, but one where masterpieces abound, and where a powerful telescope can reveal the hidden beauty in every faint patch of light glowing far off in the night sky. An accomplished artist does not spring into being fully formed. It can take years of practice and exploration before a creative talent matures and is ready to tackle big subjects on a big canvas. So too with the Hubble Space Telescope, which has been in orbit around Earth and capturing images of the heavens for nearly 2 decades. Yet, despite a long and colorful career, it is arguably only now that the Hubble is producing its greatest masterpieces. One reason for this is that the Hubble was originally designed to provide the sharpest, most penetrating view of the universe possible. But this means it cannot see more than a small portion of the sky at any one time. A single frame of Hubble's most advanced camera would cover less than 1/10 the diameter of the full moon. And that means some of the most interesting objects in the universe are much too large to fit in Hubble's field of view. When Hubble was launched, astronomers had a long list of things they wanted to see. Now that Hubble's seen them, astronomers have the luxury of being more creative. That means using the Hubble to capture images that are both wonderfully sharp and breathtakingly large. In principle, it's easy to do. It just takes time. With time, you can point the telescope over and over at adjacent portions of the sky. This leaves you with dozens of separate images. But when assembled like a mosaic, they become one giant picture. When you're trying to take in something as vast as the universe itself, it's an approach that can't be beat. That's precisely what astronomers decided to do when they wanted to get a sense of what the entire universe was like when it was less than half the age it is now. First, they chose a relatively empty corner of the sky that was largely free of stars and nearby galaxies. The best place to do this turned out to be just off the corner of the Big Dipper, one of the most recognized star patterns in the night sky. Compared to the Big Dipper, the area astronomers examined is small, a narrow strip that can easily be covered up with an outstretched finger held up against the sky. But to capture even this small a slice of the universe, Hubble had to take more than 500 separate images using a variety of different filters. Ultimately, all of this information was assembled into one giant mural, a cosmic group photo that includes at least 50,000 individual galaxies. To let your gaze wander across the single strip of the night sky is to experience our universe in all its vastness and variety. Only Hubble could create a view like this one, a view that opens up more of deep space to the human eye than any other image in history. Looking more closely, Hubble has found that this random sampling of galaxies contains surprising diversity. Some of the galaxies are spiral-shaped, like our own home galaxy, the Milky Way. Yet others appear jumbled and distorted. These galaxies are still under construction. Because they are so far away, their light has taken billions of years to reach us. Hubble sees them not as they are now, but as they were billions of years ago when the universe was just emerging from its tumultuous beginnings. Much closer to home, Hubble's ability to build a mosaic out of many smaller frames means that we can witness the assembly of an entire galaxy on our cosmic doorstep. This galaxy is smaller than the Milky Way, but it's relatively close. Instead of taking billions of years, its light takes a mere 12 million years to arrive here, so it makes an ideal subject for the study of galaxy formation. Like its more distant counterparts, The galaxy is not a graceful spiral, but a bright and chaotic jumble of stars. Its irregular appearance is the result of a collision between smaller galaxies that gravity has pulled together to make a larger system. This forced collision has triggered a dazzling burst of star formation. Here we see thousands of young stars, along with splashes of diffuse pink light, the glowing clouds of hydrogen gas where new stars are being born before our eyes. From the universe at large to a single galaxy, Hubble has revealed beauty and insight at many levels and over great distances. But perhaps its greatest masterpiece comes from its exploration of the nearest star-forming region to Earth. The light from the Orion Nebula takes just 1,500 years to reach us. It's even faintly visible to the naked eye as part of the constellation Orion the Hunter. A pair of binoculars is enough to reveal that it's not an ordinary star, but instead looks more like a small patch of mist in the sky. Around the world, telescopes for years have revealed that patch of mist as an impressive nebula where new stars are being born. But until now, no telescope has been able to show us the Orion Nebula at this level of detail. More than 500 Hubble images were used to create this exquisite mosaic. Through Hubble's eye, the nebula is revealed as a vast, billowing field of gas. Its structure is like an oyster shell, opening toward us. At the center is the trapezium, a cluster of 4 intensely bright giant stars, 100,000 times more luminous than our own sun. These stars produce enough ultraviolet radiation to energize the surrounding hydrogen and light up the inner portion of the nebula like a flame inside a lantern. These stars also generate powerful winds of high-speed particles, which are pushing at the gas and gradually driving it away from the center. With the Hubble, astronomers can now study every wrinkle and fold in the nebula's complex structure to better understand this process. To gain even further insight, the Hubble image has been combined with an infrared view from the Spitzer Space Telescope. It shows more activity and structure in regions where the gas is too cool to glow in the part of the spectrum visible to the naked eye. The colors that add so much beauty to the image are also the key to understanding the chemical composition of the nebula. Wisps of green light are partly due to atoms of sulfur, while some of the red light around the outskirts of the nebula is produced by chemical compounds that are rich in carbon. And there is more. In one of its most celebrated discoveries, the Hubble has confirmed that the Orion Nebula represents a new generation and a new beginning for thousands of stars. When Hubble searches among the nebula's feathery filaments, it finds ample evidence that new solar systems are being created here, much the way our own solar system came into being billions of years ago. Looking at this magnificent image, just one among so many great views from the Hubble, we come, in the end, to a deeper realization. It's not simply abstract beauty that draws us to this masterpiece, but a feeling that within its glowing wonder is an underlying truth that tells us something about where we came from, a truth that connects us directly to the universe we observe.